Just 2 minutes only, not more. I will restrict myself to where available space. Okay. Reasonably okay, I think. 1 minute. Little his side, that side, okay, nothing to worry. No point in wasting too much time. Okay. Done. It was raining here, so I waited for rain to stop. Luckily now stopped. Hope rain will not come once again. Rain stopped now. Hope it will allow us to take the class. Consider the boundary here. Okay. Take a limit here also sufficient. Right. Fix the limit here over. Fix this side. Okay. Put the mic on. It is slightly raining, not a severe rain. If it becomes unavoidable, I will stop the class. This type of rain, okay. Now we stop now. Just let me know. Voice clear? Is the voice clear? Voice clear? Okay. See, influence line diagram, I will tell simply supported beam. I will put here now. Simply supported beam, span L. I will call the beam as AB. See, A is left end. It's also important. I will call A means it is left end. Don't by heart AB. B is right end. And also, along with that one, also consider any point. Consider any point P, any point P, where in the member, in between, any point P, say at small a from left end, or small b from right end, so that, remember, your a plus b will be equal to L. Clear? any point P where small a is from left hand, actually it is quality, it has gone upper side, Amisha. Quality is not, my quality is not good. I should improve the quality. Otherwise I can't see anything. Okay. Oh, I should slightly lower the board. Okay. I slightly lower the board so that what I wrote just now is not fully visible. I slightly lower the board and lift the board. Okay. Actually, not lift the board, lower the board. Okay. Okay. The side, don't bother. One side slightly got lifted. Don't worry about those. Okay. Now everything is okay. In case anything goes out of board, now visible. Now fully visible. What I wrote? Simply support beam span L. AB is the beam name. A is the left hand. B is the right hand. Also consider any point P in the member somewhere in between, anywhere, which is at A from left hand, B from right hand. Visible now? What all I wrote? Fully visible? Now, what all I wrote? You are not answering. What all I wrote? Visible? Yes, okay. Now, I will put the sketch here. That is, the beam is like this. See, this is the beam. This is A, this is B. The span is L. I will do one thing now. First I will put full span. Basic definition is span L. Now, some point here in between, P, which is from here A or from here B. Okay. Now, make a note here. Make a note. We require ILD for 1. Vertical reactions at supports. Vertical reactions at supports. There, two parts are there. A, that is VA and VB. Make a note here. For this, suppose a beam AB is there. See, AB beam. We want ILD for VA, ILD for VB. I told any point P is there. Tell me, for this, that point P counts or considered or not considered. I got a simply support beam, VAB, I want ILD for VA and VB. That's all. For that, is that point P considered or not considered? Is that point P considered or not considered? Or does it matter where is P? Fast. Does it matter where is that point P? If I want ILD for VA or VB? No, does not matter. Remember, note, for this, we do not consider the point P. Consider that P. Okay, then second, this is vertical reaction. See. Second one we want is, we want ILD for bending moment and shear force anywhere in span. Say at P, because why? P is anywhere. I told P is any point. Say at P. Now, that is what? ILD for, we read, bending moment at P and also shear force at P you require. Now tell me, note, for this, that P considered or not considered? Tell first. For this one, P considered or not considered? When I want ILD for bending moment at P considered. For when you want ILD for VA and VB, P not considered. Now, when I want ILD for BM or shear force at P considered or not considered? First part considered. Or this P is very much considered. Very much considered. This is all I should not give first of all. I am making crystal clear concept. Okay. Or you can tell here, when you do ILD for VA and VB, tell the standard points. This all I am making why? To make concept crystal clear. Slowly we will do. I will not go beyond a limit in ILD. Understanding the basic and application is what I am covering. Otherwise, 20 classes you can take. Tell me. When I want ILD for VA and VB, standard points, which one? Which are the standard points? Standard point means salient points, which are required. A and B. Standard points are A and B. Whereas for this, whereas for this, standard points are, some people will tell what is standard points. They will tell it is called salient point. I call it standard point, my wish. When you come to my class, what I tell, follow that one. Salient point, difficult pronounce, salient, sometimes people salient. Standard point, that point should be considered. Now tell me, when I want ILD for BM at P or shear force at P, standard points, which one? It is, standard points are A as usual, B as usual, A and B are anywhere there, and also P. Crystal clear? Tell me, crystal clear or not? Because accordingly you have to move. Along with BMP, P also considered. Okay, now start. I'll give recap for you. Recap. First we want ILD for VA. I won't put numbers now. ILD for VA you require. See. Or 1 minute. I'll put a beam here first. Small recap. Recap. Later, I will put the result finally. See. If this is the beam, this is A, this is B. Now, L is the span. P is not there. Here, if you remember, this is the ILD for VA. 1 here, 0 here. This is ILD for VA. Last day I am writing once again. Then, same way here, 0 here, 1 here. This is ILD for VB. VA in the upward direction, VB upward, so plus plus. These two are already over in last class. But I will explain more about ILD. These are already over last class, yes or no? Then something happened, I stopped. When I was about to start bending moment, something happened, net problem. Okay, now start. Now, next I am going for second part. Up to where I can go, I should see the border line. So that should not go beyond the line. 1 minute. And then after writing everything. Okay. Now I will go for second part. See, this is the first part. Now start second part. ILD for bending moment and shearing force at P. One by one, separately. ILD for bending moment and shear force at P. See correctly now. Remember, I told you, now A, B and P also considered. Okay, start. First consider. Subdivision. ILD for bending moment at P. First ILD for bending moment at P. After I finish that one, I'll go to shearing force. See, as I told earlier, ILD for any stress function is a graphical representation of the variation of the stress function when unit load is moving along the member. Or, if I once again write, if you use that definition here, ILD for bending moment at P is graphical representation of the variation of bending moment at P. Variation of bending moment at P when unit load is moving along the member, or when a unit load starts from A, goes that side, goes to P, and then further goes to B. When it travels for entire length, how the bending moment at P will vary. That is the ILD for BM at P. Clear? If the unit load is moving along the member for different position of the loads, you have to calculate bending moment at P, then plot it. That's how the BM at P will vary. Clear or not? Clear? I will not hurry. Basic concept I will make fully crystal clear today. Clear? Okay. Now, our movement of, we have to consider unit load. So, unit load should be actually, what you have to do is, you have to place load here, load here, load here, load here, load here, here. Infinite points are there. Not required. You take at a, what? A point at unknown distance. Tell what you take distance, tell me. I told you. You take the load at a point at an unknown distance or variable distance, so that by substituting that one, you can place the load wherever you want. What is the distance equal to? Load distance. What I called last time. When you place a load for getting ILD, you should not place it at a known point. You should not place it at a known point. It should be unknown point with a variable there. So that variable, by substituting the value, you can move the load. What is that variable? Last time I told. What is that variable? No, what is that variable? X. So, what to do is, see, consider an unit load. Unit load means 1. Where? Anywhere in span. Anywhere in span. Say, anywhere in span means say at a unknown point x, comma, at small x from. Tell me where. You can take x from A, anyway, origin you can take any point. Remember, origin, you see, there is no rule in structure engineering that you should take x from where. You can take from anywhere you want. But when you put the limit, you should see variation with respect to that origin. So to prevent complication, we will take either from left hand or right hand. In India, usually we take left hand. Okay. At x from, not red point, x from A. A. At x from A. Anywhere. Okay, see. Now, if I take this way, can I get the ILD for BM at P in a single stretch, like last time? Tell me. Can I get the ILD for BM at P in a single stretch? See, when I got ILD for VA, I placed at x, I put x equal to 0, x equal to L. When I want ILD for VB, I placed at x equal to 0, x equal to L. No other point is there. So we got linear variation. Now, that way, in a single stretch, can you get it now? No, you cannot get, because, why? In between A and B, what is there? 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 Between A and B, what is there? There is a point P, which is standard point. Or, I will give an example for you. You are going by a flight, Bangalore to Mysore. Take off from Bangalore, land in Mysore. Clear? Starting point Bangalore, ending point Mysore. Over. No stop in between. You can't tell in between. Please give a coffee stop or tea stop like that. No stops allowed. Stops are not allowed. So take off from Bangalore, land in Mysore, directly journey 0 to, say, 150 kilometer. Now it's not 150, say 0 to 130 kilometer. Okay. Clear? That is for VA and VB. Clear or not? 0 to 130 kilometer. Direct flight. Take off and land. No discussion in between. No stop in between. Clear? Clear or not? No stop in between. Yes. But this is like a bus journey. You know, nowadays bus journey is there. Bangalore to Mysore bus journey, actually what they do is, they don't allow in between passengers. Passengers are not allowed. But in between, they give a coffee break. You know usually where they give coffee break, people know it. Most pop, nowadays I don't know. Earlier, see a bus where ticket is only from Bangalore to Mysore. No other ticket. You cannot go to Mandya in that bus. Midway, most earlier all I remember, it used to stop at Maddur, correct? I think Maddur. Yes or no? Maddur bus used to stop earlier. Nowadays I don't know. Someone told nowadays Chanpatna sir anta adilli provilla. Maddur is a popular in between. Yes or no? See, like Maddur, okay. Like, see, Bangalore here, Mysore here. This is Bangalore. Those who are not knowing Karnataka map, you just believe me. Bangalore, you know it. Bangalore. Mysore, you heard it. Maddur Vada. Imagine total 130 kilometer. Imagine Bangalore to Maddur is 80 kilometer. This is 70 kilometer. Tell me, now, your journey is from where to where? Tell me. Your journey is from where to where? Earlier, if it is a flight, 0 to what? 130. If you go by a flight, 0 to 130. See, 0 to L. When you want ILD for VAVB. Now, from Bangalore, go to Maddur. Stop. Yes, take some coffee. So, journey from Bangalore to Maddur is 0 to 80 kilometer. Then, from Maddur to Mysore, tell the distance. Tell me. Meter reading. Suppose you set the meter 0 here. See, suppose speedometer, you set 0 at Bangalore. Start the journey. When you reach Maddur, it will show 80 kilometer. So your journey, first journey is 0 to 80. When you once again take off from, start from Maddur after coffee, tea, etc. and land in Mysore, your journey is not 0 to 70. Tell the answer. Your journey is not 0 to 70. Your journey is what? 0 to 80 Allah. It is 80 to 130. See, it is from here. If I take X from here, see, if I take X from A, then your journey is 0 to 80, then 80 to 130. Or remember, very soon I am uploading a class in YouTube for this limit problem. But anyway, remember, limit is always what? Starting point to ending point distance from origin. See, start here. Your origin is A, permanently fixed from here. When you start here and stop here, start from 0, end at 80. When you start once again from Maddur, your speedometer is showing 80 only. It is not 0. You should not tamper the speedometer. Should not disturb speedometer. Coffee break, no tickets issued there. So, the speedometer will show what? 80 here. When you reach Mysore, it will show what? 130. Or 0 to 80, from 0 kilometer from Bangalore to 80 from Bangalore, then from 80 from Bangalore to 130 from Bangalore. So, if I take X from A for what? X from A, here limit will be, if the load is between A and P, if it is between A and P, Bangalore and Maddur, you are anywhere between 0 to 80. When you cross over Maddur, you are anywhere at what? After 80, but before 130. Or, tell me here, limit. For load between A and P, we will take X from here only. We will take X from basic derivation. Don't change the X. You take X from here only. Wherever you are, speedometer is set at Bangalore. Tell me answer. Limit. 0 to, how much? For A to P, limit. 0 to. A to P, limit. 0 to A. Tell me. P to B, limit. P to B, limit. B will not come. P to capital B. A to point P, 0 to small a. And P to B, point P to point B, limit. What to, no. This is 0 to A. You require two limits. A to P is 0 to A. P to B is measuring from here only. 0 to A. No. First is 0 to A. Second one is A to L. So remember, if you take here, this journey is, if I take here, this is 0 to A journey from here to here. This is A to L journey. Crystal clear? 0 to 80, 80 to 130, because wherever you are measuring distance from Bangalore only. Crystal clear? I will not explain once again now. This concept, once again I will not explain now. I will start the ILD now. Again and again I will not tell. I will simply put the limit. First is 0 to A to B. What is A to B? How it is A to B? 0 to A, then measurement from here, A to L. Crystal clear? Yes. Or, see, suppose the beam is, see, I tell now only. Suppose the span is 8 meter. Suppose the point P is here. You take X from here only, either here or here. Both are X from same point. Then, suppose this is 3 meter. This X limit is 0 to 3. This X starts from here. It is from 3 to 8. 0 to 3, then from 3 to 8. See, 3 to 8 means 5 kilometer covered. See, when you tell 0 to 80, 80 kilometer covered. When you tell 80 to 130, means 70 kilometer covered. The difference will cover the distance. If crystal clear, I will not talk about limit now, unnecessary waste. That's why in the beginning only, I clear the complete limit. Clear? Okay. Now, not consider this one. This all I will remove now, because my recap is not required now. Okay. Even this also I can remove. This also I can remove. Okay. That I will see later. If required, I will maintain. Okay. Start now. So, X from A. Now, very important. Don't change this for X from A. X from A. Okay, now, see, now consider case 1. Case 1. You make a note here. You should write a note. I am not writing. There is a point P here. Therefore, single stretch you cannot do. You have to consider find the BM at P for for load occupying two different portions. Once you want to consider load anywhere from A to between A and P. Next you want load after P, before B. So that by putting limit, we can put A to P, P to B, but both the places we are taking X from A only. X from A only for both cases. For both cases. Okay, sir. Case 1. Unit load anywhere between A and P. A and P. See, anywhere between A and P, that is at a point X, comma, X from A. X from A. Okay, start. Now, put the beam here. Correctly put the beam. This is A, this is B, this is that point P. Okay, point P randomly. Now do one thing. This is A, this is B, this is L. This reaction is called VA, this reaction is called VB. Your unit load is somewhere here at a point X. Unit load means one unit load. 1. At a point X. At X from A, I will mark here X from A. See, same argument for shear force also. So later when I go for shear force, I don't have to write this sketch once again. Okay, start. Now, I want to find BM at P. For that, I require reactions. Okay, for that one, do one thing. First write, to get reactions, Actually, you know the answer. Actually, you know the answer. Why? VA equal to L minus X by L, VB equal to X by L. See, you remember, VB will come X by L, X is red color. VA will come L minus X by L. This I already told last time. See, when the load is at X from A, this reaction is load into other byspan. This reaction is also load into other byspan. Still, to make complete solution, sigma m about A equal to 0. Waste of time. Clockwise positive. See, minus VB into, this is not bending moment. This is moment. Here clockwise positive. Minus VB into L plus 1 into X. See, X I am using red color. Equal to 0. Your VB will come what? Plus X by L. So I will enter the answer here. Entered. Then sigma V equal to 0. Take upward positive. Plus VA plus VB minus 1 equal to 0. Or plus VA plus X by L minus 1 equal to 0. Or your VA equal to, take that side, 1 minus X by L. Or you can take L minus X. Red color. L minus X divided by L. VA. Okay, enter here. L minus X by L. Okay. Now start. Now, bending moment at P. Remember, this is bending moment. I shouted how many times, I don't know. Now you should not use clockwise, anti-clockwise. People, those people they use, if you look left side clockwise positive, if you look right side anti-clockwise positive, that's all crudes are without sense. You tell bending moment. Our sign is sagging positive. So we are drawing ILD for BM at P, considering sagging BM equal to, how much answer, tell me? I want BM at P. Okay, look this side. It is plus VA into what? Plus VA into how much? Tell me. Answer. BM here. Plus VA into. Actually, plus VA not required. You have entered the answer there. You have entered the answer there. What is the answer? L minus X. See. Okay, plus VA into how much? VA into. First. Tell correctly. VA into. Should tell the answer. VA into X. How? BM at P I want. I want BM at P. Plus VA into X. What is this? Where all you get these ideas from? I want bending moment at the point P. VA into. How much? Bending moment at P I want. VA into. Okay, we will do slowly the class. We won't hurry. I can hurry and finish. But if I do slowly, maybe I thought first, after completing all the ILDs, I can take some numericals. No, tomorrow I can take. I do not want to hurry and finish everything. No. Once anybody will go through this class, any day he should understand correctly. See, last time, ILD for VAVB, the crystal clear, I explained. Same way, I will complete these two. Abba, VA into A. How you got ideas? VA into, see here bending moment. VA into A minus what? 1 into, red color 1 into how much? Minus 1 into, answer. Bending moment here I want. VA into A minus 1 into, how much? Tell the answer. Minus 1 into. Minus 1 into, see the diagram there. Bending moment at P, remember, bending moment, you have to consider only one side. That all I will not tell now. Someone will tell, sir, why you are looking only one side? I will tell, leave my class, don't come to my class. Sigma m, equilibrium, you have to look entire beam. When you want bending moment shear force, only one side. Which side? Any side of your choice. If you want, write it. But you should not write because it is over thousands of times now. 1 into A minus X. X is red color. 1 is black. Okay. 1 into A minus X. Hey, unit load. You be black color only. You are not red. 1 into A minus X or equal to VA equal to L minus X divided by L into A minus 1 into A minus X or equal to L by L is 1. 1 into A is A. A minus A by L into X again minus A plus minus 1 into minus X is plus X or A will cancel or equal to, if I take X outside, it will become 1 minus A by L, correct? 1 minus A by L, or further if I simplify, it will become X into L common, L minus A divided by L. See, equal to, tell the answer. Therefore, bending moment at P equal to sagging positive. Tell the answer. You know that L minus A equal to what? Tell me. See, you know that L minus A equal to how much? L minus A equal to. What is the sketch there? Total length is L, left is A, L minus A equal to B. This is B or equal to X into B by L, correct? Or I can put equal to X into B by L. Or I can tell directly, can I write X by L into B? Can I put this way? Tell me. Or this shows that it is linear variation. Why linear variation? Linear variation because X power 1, highest power of X is 1. Crystal clear? I can write X by L into B. Clear or not clear? Tell me. Clear. Now do one thing. Now think a little. I write here. Think a little. You know that when you want bending moment, you can look any one side, yes or no. You can look either left side or right side. Wherever you want bending moment, you have to look only one side. For finding BM here, we look left side, correct? Now, yes or no? We look left side. Tell me yes or no? We look left side and got the answer. Whereas, right here, by chance, when you want BM at B, it of left side, suppose you look right side. Because I told earlier, when you want BM or SF anywhere, you look either left side or right side. Some will ask, sir, which side? Whichever side is comfortable. I told you, if you are in a bus or a train, metro train, if a door is here, door is here. If you are near this door, get down by this door. If you are near this door, get down this door. You use that door where it's easy for you to go or no disturbance is there. Suppose, for some reason, heavy people are standing here. Here, nobody is there, empty. Then you go that side where what? People are lesser. Suppose you are in a bus. You are in between the bus. Front in Bangalore, front side is ladies' side for getting in. Getting out, no problem. Suppose ladies' side is vacant, nobody is there. This side full crowd is there. Go front side and get down. Or suppose men's side full vacant, that side fully occupied. Go this side. You look whichever is easy side. Therefore, suppose we think and write BM at P, sagging positive. If I look this side, what you will get? See here. Bending moment, sagging positive. This is plus. This is plus actually. Plus what? X by L into how much? Tell me. Suppose instead of looking left side, if I look right side, your bending moment will come. X by L into how much will come? X by L into how much will come? X by L into
x by L into, if I look right side, x by L into how much? You have to tell the answer. Into how much? Look there. For BM at P, you look right side. X by A na. Ayyo. Illi bending moment. Look this side. X by L. Bending moment. No clockwise, anti-clockwise. Sagging. X by L into B. Correct? Right. Oh. What? Tell me. What? Oh, same answer. Same result. Oh, same result. Yes or no? Irrespective of you consider left side or right side, answer should always come same. You know in my class, this I told lakhs of time. Yes or no? Whether you consider left side or right side, shearing force or axial force or shearing force or bending moment or shearing or torsional moment, irrespective of which side you see, both sides should give same answer. If you remember, I used to tell, if different answers are coming, I used to tell that is the last day of my teaching. Yes or no? In case when I look this side, answer comes 80. When I look that side, answer comes 70 or something else. Not 79.99 is okay. If I get something else, I told that is what? Last day of my teaching. Right at that time, I stopped the teaching. It has never happened so far, will not happen now, will not happen in future also. As long as my brain is working, it will never happen. So, right here, oh, unnecessarily we simplified. Finally, you got answer which you get by one line only. See, X by L into B. Yes or no? Tell me. Just make a note. Oh, same answer. Correct or not? Yes. Now tell me. This X varies from what? Tell me. This is X is taken from A. So this X varies from 0 to how much? I want load to start from A and finally to stop at P. I do not want the load to cross over P. Why? Because if the load crosses over P, then for BM, one will go that side. VA into only A will come. See, if the load goes that side, when you do bending moment here, then this one will not come. So this varies from 0 to, this I told already limit. 0 to what? This variation is 0 to. 0 to, this much time to vary. Load is moving from A to P. Load starts at A, load stops at P. And X is from A, 0 to. You are wasting lot of time. 0 to. If you don't answer, what I can do? This limit for X, 0 to. X, limit for X. Load starts at A, finally stops at P. When the load is at A, what is the X value? When the load reaches P, what is the X value? Where you get all these ideas from? X is a variable, limit for X. Yalla. What I can tell? Load starts from A and stops at P. I already told the answer there. See? When the load is at A, X equal to 0. When the load reaches P, what is X equal to? When the load reaches P, what is X equal to? Abba Sadhya, 0 to A. Correct? Okay, start. Now, substitute X equal to 0. X equal to 0. That is what? Unit load, or I'll do one thing now. I'll take other way. I'll start here. Unit load at A. That is X equal to 0. Correct? Then bending moment at P equal to, put X equal to 0. What is the answer? 0 is there. 0. Then unit load at P, that is X equal to A. X equal to A. Then bending moment at P equal to, see here, A into L by B, or I can put AB by L. Yes or no? I can put AB by L, correct or not? I can write A by L into B is AB by L. Correct? AB by L. That is, when the load comes to P, load reaches P, then BM there is AB by L. Actually, that answer you know it. If a load is placed at a point, if the load comes to same point, you know bending moment, WAB by L. WAB by L, how much W equal to here? Formula for when the load is here, BM there is WAB by L, eccentric load. But W equal to how much here? W equal to. Here W is not there because W equal to how much here? WAB by L is the formula. How much W equal to here? How much W equal to here? There is no W equal to how much here? W equal to. Here W equal to P. If a point load W is at a point, BM there is WAB by L. But here W equal to 1. Since W equal to 1, 1 into AB by L. Over. Okay. This is what? Variation. Therefore, if I put the B, 1 minute now, I should say space there. There is space problem? No, space problem is not there. So, therefore, see, if this is the simply supported beam, if this is the point P, if this distance is A and this distance is B, span is L, then ILD for bending moment at P for AP portion is 0 here, this is L, 0 here, linear variation, here ordinate is AB by L, sign is plus, sign is plus, this is the hatchet sign plus. This is the ILD for bending moment at P when the load is moving from A to P. This is ILD. This is AB by L. See, this is AB by L. Other is, this is A, this is P, this is B. Other side still pending. Other is pending. Clear now? This is the ILD for bending moment at P when the unit load is anywhere between, when the unit load moves from A to P. Okay, A to P. Clear? Clear or not? That is the ILD. You are not only clear. ATB, sir. ATB means? I don't know what is ATB means. You wrote ATB. ATB means I don't know. Okay, now I will remove this one now because I want the space for other one. This all I will remove. Because if I rub this one, shear force again I struggle. Okay, now this is case 1. Now go to case 2. Case 2. See, case 1, unit load will be anywhere between A and P. Now, case 2, unit load anywhere between P and B. P and B, that is again at a unknown point X. At X from A only, don't change. X from A only. Now see, now your bus has left the Maddur and reaching Mysore side, but speedometer is still from Bangalore only. That is this way, see. This way. Point P is here. This distance is A. This distance, wait, I don't waste the space. This is A. This is B. A point, B point, P point. Now unit load is somewhere here. How much unit load? 1. 1. Distance is from here X. So can you tell me limit for this X? Tell the answer. Limit for this X. This X is, tell fast answer. Now load will leave the earlier load started at A and stopped at P. Now it start from P, somewhere near Srirangapatna. It has gone Mandya like that, somewhere here. Limit for x, tell now only. Limit for x, tell now only. Limit for x now. You already know it. First time 0 to A, 0 to 80 kilometer. Now Maddur to Mysore. Limit. You are waiting lot of time. X to L. Abba, how it is x to L? Limit for x in terms of x. A to L. A to L. I don't know why this much confusion. A to L. Already I clarified earlier. 0 to 80, 80 to 130. A to L. Okay, start. Now, this reaction is VA equal to this reaction is VB. You don't have to find again because right here, same answer will come. See, same calculation will repeat because here load is at x from A, or see here, minus VB into L. Okay, L I not done. Okay, L L. Minus VB into L plus 1 into x equal to 0. VB will come plus x by L. VB will not change. VA will come L minus x divided by L. Same answer will come. Or take it once again. See, minus VB into L plus 1 into new x, not that x. Don't see that x now. X equal to 0. Okay, now tell me. Bending moment at P. Tell me. Better, see here, I am looking left side. Whereas, suddenly I told, if you look right side, what happened? Tell me. To get bending moment at P, now tell me. Looking left side better or right side better? Earlier, when the load is here, when you look left side, lengthy expression came, finally you got the answer. But when you look right side, you got easy answer. Now tell me, to get bending moment at P, look left side or right side? Left side is better. Why? Now left is better. Directly you get answer. Tell the answer here. It is plus VA into L minus x. L minus x divided by L. Ayo, VA, where I am? Ayo, plus VA into A. See here, VA into A or equal to plus what? L minus x divided by L into A. Now also, highest power of x is 1. Therefore, this also linear variation. This x varies from, remember, this x varies from what? This x varies from 0, not 0 to, varies from A to L. Okay, start. Same argument now. If you look that side, answer, see here. Answer is x by L into B, x by L into B minus 1 into this distance. This distance is x minus A. You write that way, simplify, my guarantee, it will finally come equal to L minus x by L into A. Guaranteed. You can believe me. Guaranteed it will come. Okay, start. Now, same way. Start. Unit load at where? At A, not A. See, this is unit load starting from A, stopping at P. This is unit load starting from P and ending at B. Bangalore to Maddur. Now, Maddur to Mysore. Unit load at P. Therefore, unit load at P, that is your x equal to A. Then, bending moment at P equal to x equal to A. L minus A by L into A. But L minus A equal to how much? Tell me. What is L minus A equal to? What is L minus A equal to? L minus A equal to? L minus A equal to? This but time for L minus A. L minus A equal to, wasting time, lot of time. This way if you waste the time, time is wasted. I can tell, but I want the answer to come from you because suppose B, L minus A equal to B. Therefore, this will become B into A by L, or you can remember here, L minus A equal to B. So this will be equal to plus AB by L. Oh, same as last time. And unit load at where? B. This load, Bangalore, stop at Maddur. Finish your coffee. Start from Maddur, reach Mysore. B. That is, X is from A only. X equal to L. When you put X equal to L, bending moment at P equal to L minus L. Oh, there only comes L minus L by L into A equal to 0. Therefore, if this is the beam, if this is A, this is B, any point P here, you when the load, see, ILD for A to P is this way. Now ILD is plus, see, here, when starting point once again, AB by L, ending point 0, close here, hatch here. Okay. B. This is what? This is ILD for bending moment at P for which portion? Tell me. For which portion? This is the ILD for BM at P for AP portion. That is ILD for BM at P when the load is moving in which portion? When the load is in for which one? Load is in what? In the PB portion. PB portion. Okay. O1. Fully clear? Fully clear or not? When the load starts from A, reaches P, BM at P will vary from 0 to AB by L. When the load leaves B, still BM is AB by L. When it goes to B, BM at P is 0. Clear? Okay. Now, therefore, I will tell now, space problem is there. I do not, because next class I am giving full summary and explanation. I will use the space here. Therefore, you cannot see me. If you write the beam this way, next time summary I am giving. If this is the point P, if this is A, if this is B, if the span is L, your ILD for bending moment at P for the entire beam will be, this is L, because I am letting small because next class I am giving full explanation. Don't worry. Next class I am explaining fully all the concept. It is this way and this way. This is ordinate is AB by L, sagging BM at P, sagging positive, plus. This is A, this is B, this is P. This is the ILD for BM at P for full AB portion. Fully visible? Tell me. Fully visible means I will start shear ILD for shear post now. I want to finish today because tomorrow will be discussion. Tomorrow will be discussion about the variation and numerical problem. How to use ILD. Okay, start. I won't waste time now because I am explaining once again tomorrow. Start now. Second, now go for ILD for shear post at P. Shear post at P. Nodi. Once again, same thing. Consider an unit load anywhere in the span, say at X from A. Note, you cannot, see, note, you cannot place the load directly between A and B without bothering P. No, because this is not a flight journey. In between Maddur, coffee stop is there, coffee break is there. So, you have to once place the load after A, between A and P, then again place the load after P but before B, but both the places take X from A only. So case 1, unit load anywhere between A and P, same diagram. Okay, reaction also will come same way, but we want not bending moment. What do you want? Tell me now. What do you want now? We do not want bending moment. What do you want? I rubbed everything now. Now we do not want bending moment. What do you want? Now it is very simple. We do not want bending moment. What do you want? Now we want variation of what? SFD, shear force ಅಷ್ಟೇ. Variation of, not SFD, sorry. SFD is the diagram. Variation of shear force is called SFD. If you tell SFD, shearing force diagram, it is not variation of shearing force diagram. It is variation of shear force. Okay. Grammar problem. Okay, start. Now, calculate shear force at P. Remember, sign convention for shear force is left up positive, right down positive. If it is not clear, you go back to my class of SFD BMD. 100 classes are there. Go through it, study and come back. I cannot waste time on shear force. See, if you look left side, here also look left side. If you look right side, here also right side. I used to tell, if you buy bus ticket, go to bus stand. If you purchase railway ticket, go to railway station. Suppose you decided to find shear force looking this side. You follow the sign convention for this side only. Or suppose you decided to look this side. Then you should see sign on that side. When you want a journey, you can go either by bus or train. You will go to same place. Whether you go by look left side or right side, answer has to come same in my class. Not my class, for that matter, in every class. Okay. Shear force, tell me. Correctly think and tell me. I want shear force here. If I look left side, see, left side, answer is, if I look left side, here also left side, plus VA minus 1. Correct or not? See, shear force here, only load, no distance. Plus VA minus 1. Correct? Plus VA minus 1. Correct or not? Only force, no distance now. Shear force equal to plus VA minus 1. You tell me correct or not? Correct. Okay. Or substitute equal to plus VA. What is VA? L minus X divided by L minus 1, or equal to L by L is 1 minus X by L plus 1. 1 and 1 will cancel, or equal to minus X by L. Correct answer? Or power of X is 1, therefore linear variation. You write it outside, minus X by L. Or this is if you look left side. Or see, make a note here. Suppose I look right side. See here, if I look right side, then shear force is look this side. If you look right side, here also look right side. Right down is positive, right up, its answer is shear force at P equal to, if I look right side, it is again minus X by L. Oh, same answer. Yes or no? See, when you look that side, finally came minus X by L. Start. Unit load at A, not A, unit load at A. Unit load at A, that is X equal to 0. X equal to 0. Then shear force at P equal to 0. See here, 0. Then unit load at P, that is your X equal to A. This I told 1000 times for you. A. Shear force at P equal to X equal to A means minus A by L. Therefore, if this is the beam, if this is A, this is B, if the point is P here, at A from here and B from here, see this much details nobody will give you. If I draw ILD for shear force, ILD for shear force at P, left up, right down positive, for load is AP, for AP portion. For AP portion will be 0 here. When you reach here, it is 0 here, 1.0 minus A by L, plot below A by L. Join straight line, negative sign, over. Some people, what they do is, they write minus here, put again minus here. No. Once you write minus in the diagram, don't write minus here. This is A, this is P, this is B. See, x equal to 0, answer is 0. X equal to A, answer is A by L. This is the ILD for shear force at P when unit load is moving from A to P. Okay, now start. Unit load anywhere between P and B. Same statement. Now reaction will come same. Now we want what? Now we want shear force at P. Shear force at P. Left up dot dot right down positive. Now for shear force at P, it is better to look this side. See here, easy side. How much? Plus L minus X divided by L. Or if you write, it is plus VA. See here, when you are here, shear force equal to plus VA minus 1. But now 1 has gone that side. So still the load comes up to here, shear force is what? VA minus 1. Once the load goes that side, then shear force is only VA. It is plus VA equal to plus L minus X divided by L. Again, highest power of X is 1, linear variation. Okay, start. Now, unit load at P, put X equal to A. X equal to A. What do you require? We require, therefore, then we require shear force at P. Put X equal to A. When you put X equal to A, answer is, I'll put somewhere here, space problem. Okay. Now, see. No, I do not want to maintain that one. New diagram I want. Okay, leave it. Next time, tomorrow class, I will tell more and more principle for you. Lot of principle tomorrow, very important class. Okay, now, unit load at unit, now what? Bangalore to Maddur over Maddur to Mysore. Unit load at P. That is your X equal to A. X equal to A. Then shear force at P equal to L minus A divided by L. Positive. But you know that L minus A equal to B. So you can tell plus B by L. Over. Then unit load at which point? At B. Means that is your X equal to L. When your X equal to L, then shear force at P equal to L minus L, 0 by L equal to 0. Therefore, if this is the beam, if this is A, if this is B, if it is the point P, if it is A from here and B from here, ILD for shear force at P for AP portion is 0 to minus A by L. Now, this is the ILD for shear force at P for PB portion. PB portion is when the unit load is in PB portion. Here not, see here minus came, here plus. This is, there you got A by L, this is B by L to 0. Positive. Okay, now do one thing. I will rub the board now, no problem. Combine those two. I will write here because next time I am going to final answer. See, summary I will tell you tomorrow, not today. Or see, tomorrow I will tell more and more concept. Remember, and in a simple way I will tell. See, derivation can be complicated or confusing. Tomorrow I will make everything crystal clear. You do not require derivation, just understanding required. Tomorrow, every concept will be clear. So don't miss tomorrow's class. Therefore, now I want to combine together. If simply supported beam is here, if the point P is here, at A from here and B from here, and if the span is L, then your ILD for shear force at P, left up, right down, positive, for entire beam will be join those two. See, if the point P is here, A here and B here, this is P. 0 to minus A by L. Then B by L to 0. This is negative, this is positive. This is the ILD for shear force at the point P for P, for complete beam, or I will tell tomorrow, I will fully explain. Now see, just to understand fast, don't get panic. See here, this will be tomorrow, neatly I will write A, B, any point P, this is A, this is B, this is L. ILD for VA, ILD for, I won't waste time because rough sheet, ILD for VA, ILD for VB, ILD for bending moment at P. Now P will come, jump and come. Okay, jump and come. ILD for shear force at P. All are proved now. I will tell you the real principle, systematic way to understand, and concept also tomorrow I will tell. Agreed? Tomorrow I will tell you the meaning, what this actually means, not simply ILD. What is the meaning of all this? Tomorrow I will tell. Agreed? Tomorrow I will tell you concept, means derivation is over. Or sometimes, see, if I take classes for competitive examination, then there is no derivation. I will start directly for them. ILD, okay, start. Then I will tell them simple way to draw. That I will tell tomorrow for you. But for them, I will only tell ILD for VA, go up by 1, joint right side point. VB, go up by plus, forgot right here, plus. Sign ಬರದಿಲ್ಲ ಅಂತ. ಅಬ್ಬಾ, unsigned is positive, okay. ILD for VB, 0 here, and go to 1 there. ILD for BM, ends are 0. Where is the point there? AB by L. ILD for shear force. Start from left hand, go negative side by distance A by L. Start from right side, go positive side up to here. Distance is B, so answer is B by L. That is the way I explain for competitive examination, not the speed. Slowly I will explain. But for you, I will tell tomorrow the concept also, not only diagram. Diagram, what is there? See, ILD for VA, I am not seeing there. Or 1 minute now, see. Some will tell, sir, you are seeing and writing. Why should I see it? ILD for VA, 1, 0. ILD for VB, 0 here, 1 here. BM, 0, 0. AB by L, shear force, minus A by L, plus D by L, join this way. The total drop is 1. It has got concept. What is the meaning of that drop? That all I will tell tomorrow. So today, at last class and today's class, you study thoroughly and understand how results came. Agreed? How results came, you understand. Principle, I will tell tomorrow. Principles, I will tell in the title I will put tomorrow. Basic, real principle of ILD, that I will tell tomorrow. So tomorrow title I will put ILD continued, I will write there. The actual basic principles I will give tomorrow. Okay, thank you.